Manasa Gangotri, Mysore, since 2007. And before joining the University of Mysore, Madam has served in many institutions. To name few of them, St. Philomena Degree College, Mahani's College, Vidyavardhaka, and University Evening College. The most importantly, Madam worked in Administrative Training Institute, Government of Karnataka in Mysore. So that was the greatest period that Madam could have been enjoyed in organizing more than 40 programs for preparing a training IAS and KAS, IAS KS officers, not aspirants, IAS KS officers. Madam has successfully completed 40 programs there. And Madam has done her PhD in the year 2006, and for that she got the help from World Bank Assistance and Economic Development of Karnataka. So, and Madam successfully complete her PhD in 2006. Madam also cleared both UGC NET and SLET, both she completed. And Madam is resource persons and delivered talks on current issues, research methodology, econometrics, and related topics, current related topics. Over 160 lectures Madam has delivered and made the participant skillful, and their capabilities have been increased. Madam has published 7 books, including the edited books, and published 60 research articles in peer-reviewed international journals, and contributed chapters on gender and health in 4 district human development reports, which was recently published in Karnataka by the government of Karnataka, and developed study materials for 5 courses of MA Economics, that is for the distance education programs. And Madam has a very rich research experience, and she successfully guided 12 PhD candidates and 13 MPhil candidates, and presently 8 PhD candidates are working under her guidance, and out of 8, 3 are having fellowship. Madam also worked for many projects. To name some of them: Action Research Project on empowerment of women through microfinancing in self-help groups, funded by Administrative Training Institute, Mysore. Research project on crime and social development under UGC-UPE Focus Area 2 program. Research project on district planning committees and rural development, funded by UGC-UPE Focus Area 2. Madam was also part of a research team of media and social development on the work, a case study of Karnataka, to prepare the report for the districts of Bangalore Urban, Bidar, Bellary, Davangere, Gadag, Dakshina Kannada, Hassan, Kodagu, Koppal, Raichur, Uttara Kannada, and Yadgir. Madam was also part of research and research team for statistics teams of media and social development, which was on a case study of Karnataka, where following reports were published. Presented 30 papers in national. Madam also presented 30 papers in national and international conferences, delivered more than subject-specific 25 special lectures in various reputed institutions and colleges. Madam, as I already mentioned, Madam also prepared training modules on good governance, environmental impact analysis, natural resource management, gender budgeting, domestic violence, data usage and management, equity in governance, and public distribution system, and World Trade Organization and India. Madam was also course coordinator and director for the course director for more than 40 training programs of Government of Karnataka. Conducted 30th. Madam was the course coordinator for the previous 30th refresher course. Madam also faculty for the many departments within the universities. To name some of them, the Law School of Law and the Department of Management, that is which is in Bahadur Institute of Management Studies, BIMS, and moreover, Madam is very acquainted with research skills, statistical techniques, and econometrics. She is expert in econometrics, that too particularly in applied econometrics. That's how she is capable of delivering talks in many interdisciplinary aspects on various topics. Madam, due to shortage of time, I'm not completely reading your biodata. Just I have mentioned few of them. With these words, I heartily welcome Professor Navitha Thimmaiah for this 31st refresher course on the 4th day in the second, in the afternoon session for both 3rd and 4th session. The topics given by the madam is also very interesting. You could have been seen these topics. One is on search economy and economics of crime. So which is the new area of economics for research. And another one is efficient market hypothesis, the new kind of market hypothesis. So both the topics are very new to the subject of economics, and they are gained much importance in the international discourses. And these two issues are also discussed under the sustainable development, particularly ensuring the sustainable cities. So therefore, the topics are very interesting. Madam will address both afternoon sessions. Hope you will enjoy her classes. Thank you, madam, for accepting our invitation, and I wholeheartedly invite you for delivering these two, for addressing in these two sessions. Welcome you, madam. Where is madam? Madam, over to you. Madam, unmute ಮಾಡ್ಕೊಳ್ಳಿ. Unmute ಅಲ್ಲ ಕೆಳಗಡೆ ಇರುತ್ತೆ. ಕರ್ಸರ್ ಇದು ಮಾಡಿದ್ರೆ ಕೆಳಗಡೆ ಇರುತ್ತೆ.
So thank you for detailed introduction, sir.
It was less, madam.
Sir. Anyway, it was detailed, sir. Thank you. So the whole of this afternoon sessions, we will discuss about economics of search and economics of crime and punishment and efficient market hypothesis. However time is feasible, we will adjust it in the sessions, sir, both sessions. I'll try to cover all the 3 topics. So coming to first, we will deal with economics of search. All of us know that we are talking about unemployment and a lot of other issues. Whoever is searching for something, there is information gap, and there is just a minute. There is information gap and a lot of asymmetric information, and who is searching for whatever things they need. There is gap in that. We are not able to find where the things are located, what I precisely need, and accordingly I have to take up the search activity. So there is this friction in the market when you are searching for certain things. So here, when it comes to search economics, most of the important contributions, or what we say as economics of search, most of the important contributions have happened related to labor market. That is, if there are unemployed people, how they try to search for employment, and if there are employees, that is people who give jobs, how they try to seek the proper employers or laborers for themselves. So in this activity, there is huge gap, there is lot of friction, there is asymmetric information, and there is lot of search activity involved because of gap of information. No complete information is available to both the stakeholders, the one who is searching, the laborer, or the one who is seeking the employment, or the person who is giving the employment. So first we will deal with this economics of search, a very interesting area of economic research, or even economic theory. Three Nobel Prizes for three economists were awarded in this area of economic research, right? Diamond, Pissarides, and Morgenstern and all. So they received Nobel Prize for this contribution on economics of search. So, can you please allow me to share? I have logged in my research scholar's name, Siddhartha S.
Yes, ma'am. I have
Yeah.
given co-host.
Yeah,
You
yeah.
can share, ma'am.
Because it's showing only one participant can share. Okay. Okay, is it visible?
Yes, ma'am.
Yes, ma'am.
Yes, it is visible.
Yeah.
Visible.
Yes, ma'am.
Yeah. So the economics of search, it studies the implications of market frictions for economic behavior and market performance. So as I told you, when we talk about frictions, these frictions are nothing but the interferences in the smooth functioning of the market. So there is information asymmetry, there is gap in the information, the employers are not able to find proper employees, and even the employees are not able to find the proper employers. So whatever is interfering in the smooth and instantaneous exchange of goods and services. In this case, that goods and services we are talking about is the job market. The example that we are taking is job market. So whatever exchange there, whenever there is interference in the smooth functioning of the market, we call it as frictions. The major friction in this case arises because of asymmetric information. All the stakeholders do not have perfect information about what they are searching, what they want in the market. So if I am unemployed, if I am searching for a job, given my skills, given my expertise, I don't know properly where my employer is located, who can suitably locate me or take me into employment. Same way, the employer who is in need of certain skills and services, who wants some people to work for him with certain expertise and skills, even they are not able to find where those employees are located, and there is a gap. So because of this gap, what happens? The search activity arises. So the most commonly studied problems, it arises because of asymmetric or imperfect information about the location of buyers and sellers. Buyers don't know where sellers are located, and sellers do not know where buyers are located. Proper prices information is not there. What is the exact market price, and the quality of goods and services that they trade, even that information is not properly available to everyone. So like we assume in perfect computation, there is complete information available to all the stakeholders, but it is not so when we talk about, when we see actual functioning of the market. So the key implication of these frictions is that individuals are prepared to spend time and other resources on exchange. So before the buying and selling activity happens, they have to spend some time before this exchange. So they search before buying or selling. So this is the search activity that happens because of the market's frictions, the major friction being the asymmetric information regarding buyers and sellers, the prices, the quality of goods, if it is labor, the skill sets and the services that the laborer can provide, and what kind of employer he is looking for, all these things. So the first formal model of individual behavior, that is the job seeking behavior or the search behavior, is due to Stigler in 1961. It was in the context of goods market. So choosing the optimal number of sellers to search before buying at the lowest price. So as per Stigler's model, how did they try to choose? Select the optimal number of sellers to search before I buy a certain commodity, where at the lowest price, because I want utility to be highest and I want my consumer surplus to be highest. So Stigler's rule was known as fixed sample rule. Why fixed sample rule? Because he was the model went with choosing a given number of sellers and search among them and buy from the seller who is selling it at the lowest price. So hence it was called as fixed sample rule, but it was abandoned in favor of something called as sequential stopping rules. So what is this sequential stopping rules? Choosing the optimal reservation price and buying at the first store encountered with sell set or below the reservation price. So you go on searching and you have a optimal reservation price. So what is this optimal reservation price? So you are determined about the price of that good or services that you are going to buy. So whichever shop, whichever store that is providing you at that price, you will immediately buy at that shop as soon as you find that shop which is providing that good and services at that reservation price. So this was called as sequential stopping rule. So here you go on searching in all the stores. Instead of a fixed sample, you go on searching and buy at a store which is providing the good or service at optimal reservation price that the buyer has decided. Okay. So he will buy from the seller who is providing him at that optimal reservation price. So when this gets applied to labor market, so if there is a laborer, he has that minimum wage which he is expecting. So he will go on searching for job until he finds the employer who is providing with that wage level which he is expecting, and immediately he will accept that offer which is giving him his ರಿಸರ್ವೇಶನ್ ವೇಜ್ ಲೆವೆಲ್. ಅಂದ್ರೆ ಅವನ್ನ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡಿರೋಂತಹ ವೇಜ್ ಅನ್ನ ಯಾವ ಎಂಪ್ಲಾಯರ್ ಕೊಡ್ತಾರೆ ಫಸ್ಟ್, ಆ ಎಂಪ್ಲಾಯರ್ ಹತ್ರ ಅವನು ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಕೆಲಸ ತಗೋತಾನೆ. ಅಲ್ಲಿವರೆಗೂ ಈ ಗೋಸ್ ಆನ್ ಸರ್ಚಿಂಗ್. So the momentum in this direction came in 1980s when contributions by Diamond, Mortensen and Pissarites showed that such theory could be used to construct equilibrium models of the labor market with more accurate predictions than the traditional neoclassical model. So they tried to develop a search theory where they could provide equilibrium models of the labor market with accurate predictions than the traditional neoclassical model. The equilibrium where the buyer and employer both will satisfactorily meet in the market. So that is what they were able to deliver through this search theory. So the appearance of comprehensive data on job and worker flows, which can be studied with the tools of search theory, also contributed to interest in this direction. Since we are more and more serious with data collection and maintaining the data and all, this added, the data on job and worker flows added to more interest in this search theory. So now let us move to this search theory or economics of search. So here we assume that each individual has one unit of labor to sell to firms which create the jobs. So if I am a laborer who is working for a job, I have one unit of labor to offer, that is to work, and sell it to firms. Sell it to firms in the sense I will work for the firms and then I'll get wages in return for working or selling my labor to those firms. So the valuation of labor takes place under the assumptions that agents have infinite horizons and discount future income flows at the constant rate R. That they know the future path of prices and wages and the stochastic processes that govern the arrival of trading partners, and they maximize the present discounted value of expected incomes. So here the value of labor takes place with infinite horizons. That is, he can infinitely go on searching for jobs which will give him his reservation wage or his reservation price which he is expecting for his unit of labor, and they have information about discounted future income flows. That is, what is the wages that he is going to receive, income that he is going to receive in future time with the constant rate R, that is discounting rate R, and they know the future path of prices and the wages, and also the stochastic processes that govern the arrival of trading partners, and they maximize the present discounted value of expected incomes. So what is the income that is expected over the given future time that they want to maximize? So that is called as the present discounted value of the expected incomes. Now, if UT is the expected present discounted value of a unit of labor before trade at time T. So here trade in the sense trading for his labor with the employer, whoever is buying this labor from the laborer. So UT is the expected present discounted value of a unit of labor before trade, that is before he is getting job at the time T. So what is this? It is actually the value of an unemployed worker. So if when he is employed, his value is what? UT, that is utility or his return he is expecting at the time T when he is not employed. And WT is the expected value of an employed worker. So if he is finding employment, WT is what he expects in as wage when he is employed. Okay. So during the short time interval delta T, so from T, a small time gap happens. The laborer is searching for job, suitable job to get WT. And during this short time interval delta T, the unemployed worker receives income B delta T. So in that delta T time, he is receiving that income B delta T, and a job offer arrives with probability A delta T. This is the arrivals of job offers. Andre job offer ಬರ್ತಾ ಇರೋ ಆ ಲೇಬರರ್ಗೆ ಸಿಗ್ತಾ ಇರೋ ಅಂತ ಒಂದು ಪ್ರಕ್ರಿಯೆ. So in the absence of frictions, so ಈ asymmetric information ಇದು ಯಾವುದು ಇಲ್ಲ ಅಂದ್ರೆ, ಇನ್ಫಾರ್ಮೇಶನ್ ಗ್ಯಾಪ್ ಇಲ್ಲ ಮಾರ್ಕೆಟ್ ಅಲ್ಲಿ, ಯಾವುದೇ ಫ್ರಿಕ್ಷನ್ಸ್ ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ, the probability of getting the job offers is infinite. Right? Because there is complete information about everything in the market, the probability is infinity. With frictions and search, if there is asymmetric information, if there is information gap, and if there is search happening, A, the probability of getting job offers is positive, greater than 0. And if there is no search, now what happens? A is 0. A is 0 means what? The probability of getting the job offers will be 0. Why? Because there is frictions, because there is information gap. Without search, you will not find any chance to get the job offer. So that is the arrival process. So if there was no frictions, the probability of getting job offers would be infinite. This we should focus on. only because there is information, so much information gap about so many things in the market. The probability is not infinite, but some positive number because of frictions. And because there is frictions, you have to take up the search activity before buying anything. So if you don't take up search when there are frictions in the market, then the probability of getting the offers is 0. That is what it implies. Now, if a job offer arrives, now what happens when the job offer arrives? The individual has the option of taking it for an expected return WT plus delta T. So WT is what he is expecting at time T as the wage if he gets offer. Now in WT plus delta T, T plus delta T, ಅಂದ್ರೆ ಆ ಡೆಲ್ಟಾ ಟಿ ಟೈಮ್ ಒಂದಷ್ಟು ಆಗಿದೆ, ಟಿ ಇಂದ ಸ್ವಲ್ಪ ಮುಂದಕ್ಕೆ ಬಂದಿದೆ ಅಂತ ಹೇಳಿದಾಗ, the individual has the option, he has got a job offer for an expected return WT plus delta T. So he can take it or T. Job, the one who is seeking the job, he might accept this or he might not accept this. So ಆ ಕೆಲಸನ ಅವನು ಒಪ್ಕೋಬಹುದು, ಆಫರ್ನ, ಅಥವಾ ಅವನು ಒಪ್ಕೊಳ್ಳದೆ ಇರ್ಬೋದು ಫಾರ್ ದಿ ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ ವೇಜ್ WT plus T. ಒಪ್ಕೊಳ್ದೆ ಇದ್ರೆ ಏನಾಗುತ್ತೆ, ಈ ವಿಲ್ ಮೂವ್ ಬ್ಯಾಕ್ ಟು ಹಿಸ್ ಅರ್ಲಿಯರ್ ರಿಟರ್ನ್ಸ್. ಅನ್ಎಂಪ್ಲಾಯ್ಡ್ ಆಗಿದ್ದಾಗ ಅವ್ನಿಗೆ ಏನ್ ರಿಟರ್ನ್ ಸಿಗ್ತಾ ಇತ್ತು, UT plus delta T. He is happy with that and he will not accept the job offer. So why will he not accept this job offer WT plus delta T? Might be because it is lesser than his return when he is unemployed. So on unemployed iddu leisure alli idare, null occupation anta kariತೀವಿ. Even being unemployed is called as null occupation. ಇದ್ದಾಗ ಇರುವಂತಹ ರಿಟರ್ನ್ ಗಿಂತ ಅವನ್ಗೆ ಈ ಆಫರ್ ಅಲ್ಲಿ ಬಂದಿರುವಂತ ವೇಜ್ ಕಡಿಮೆ ಇರ್ಬೋದು. ಅವಾಗ ಏನಾಗುತ್ತೆ, he might not accept it. So if the no offer arrives, still his return is UT plus delta T. So therefore with discount rate R, the UT, that is his unemployed returns when he was unemployed, it satisfies the Bellman equation. So now Bellman equation is a famous equation with which we can calculate the return for the long run, for the long time, considering the discounting rate, okay, or rate of returns. It is even used in learning curves and all, reinforced learning and all. We use this Bellman equation, okay. So now this satisfies the Bellman equation. UT is equal to B delta T plus A delta T, maximize WT plus delta T and UT plus delta T. That is, you want to maximize the expected returns from the job offer, from the wage that you are getting, that is W. And also if you are not taking that offer, if you are employed, you want to maximize UT plus delta T also. So divided by 1 plus R delta T, where R is the discount rate, plus 1 minus A delta T, then U divided by 1 plus R delta T. So rearranging this yields RUT is equal to B plus A, maximizing W and U, minus the unemployed if he is taking up the job, plus UT plus delta T minus UT by delta T. So it takes into consideration both the options of if the person is accepting that job offer or if he is not accepting the job offer, maximizing the UT. So as delta T moves towards infinity, as the time lapse moves towards the infinity, the equation becomes RU is equal to B plus A, maximize WU minus U plus U, last term U mele dash ide, where it denotes the rate of change of U, which is given in equation 2, UT plus delta T minus UT divided by delta T. Okay, so here the person wants to maximize the returns if he takes the job offer, and even if he is not taking that returns, he wants to maximize the UT, which was his expected return when he was unemployed, he or she was unemployed. So this equation 3 is known as the fundamental equation of the economics of search. So it can be even used for the valuation of the asset. So not just for job market, we can use it for the valuation of different assets in the stock market or anywhere in the market. So it can be given the interpretation of an arbitrage equation for the valuation of an asset in a perfect capital market with risk-free interest rate R. So this asset is coupon payment B, and at some rate A, it gives its holder, that is if the holder of the stock or equity, any asset, the option of a discrete change in its valuation from U to W. So a fundamental equation of such, this equation 3, we can use it for explaining the valuation of an asset in a perfect capital market. So from at some rate A, this is the coupon payment. So the confirmed returns that you are getting on the asset, and A is the rate where you are changing the valuation of the asset from U to W. Optimality requires that the option is taken if W is greater than or equal to U. So the last term U shows capital gains or losses due to changes in the market valuation of the asset. So if W is greater than U, well and good, you are earning returns on your asset. But if it is less than U, you are incurring losses. So earlier value ginta W, nimma earlier value ginta, asset value ginta W kadme agbitre, it is a loss on the asset. In most of the economics of labor market search, research concentrate on steady states. So it is situation where the discount rate, transition rates, and income flows are all constant. So you assume all these as constant and then calculate or arrive at the optimal equilibrium model. So with infinite horizons, there are then stationary solutions to the valuation equations obtained from 3 with U is equal to 0. So even when with U is equal to 0 also, you arrive at infinite value for W. You are moving from U to W. So given all the constant in the steady state, even with U to 0, when U is equal to 0, W can be infinite. Now, the aggregate matching function. So now we saw the search activity, how search activity happens, or when the person will accept that offer or not. If WT is less than UT, he might try to remain unemployed rather than going for that job offer. So when you say UT, that is the valuation expected returns when he, how can somebody get any returns when he is unemployed? Is there any possibility? Yes, there can be unemployment benefits in the market. You might be giving social security payments for people who are not employed. Most of the advanced countries, they go with this unemployment benefits and all. And the value of leisure might be, even that can be taken as U, right? So based on that, the wage offer and W, wage rate expected returns when he will get the job, can be compared with the unemployed expected returns. That is expected returns when the laborer is unemployed. So to derive the equilibrium offer arrival rate, suppose that at time T, there are U unemployed workers. So let us see that there are U number of unemployed workers and there are V vacant jobs. Number of jobs that are there in the market is V. For these U number of workers to seek those V jobs at time T. So in a short time interval, delta T, each unemployed worker moves to employment with probability A delta T. So in a large market, the total flow of workers from unemployment to employment and the total flow of jobs from vacant state to production are both A, U, delta T. So the probability of each unemployed worker moving towards employment is A delta T. So for U number of workers, it will be A, U, delta T. So this is the probability that U number of unemployed workers are moving towards employment. That is to occupy those V vacant jobs. So a key assumption in equilibrium literature is that total flows satisfy an aggregate matching function. So now we arrive at the aggregate matching function. So there are U number of unemployed workers seeking those V vacant jobs. So where does this aggregate matching function happen? Matching between job seeker and the employer, or the buyer and seller generally. Okay, so the aggregate matching function is a black box that gives the outcome of the search process in terms of the inputs into search. So you are giving inputs as search, you are taking up the searching activity, that is the input, and you will get an outcome for that input of search process. What is that? That outcome will be the job, the vacant job that was there in the market, which will be occupied by one of the unemployed workers. If the U unemployed workers are the only job seekers and they search with fixed intensity of 1 unit each, and then firms also search with fixed intensity of 1 unit for each job vacancy, the matching function gives. ಅಂದ್ರೆ ಒಂದು ಲೇಬರರ್ಗೆ 1 ಯೂನಿಟ್ ಆಫ್ ಲೇಬರ್ ನ ಫಾರ್ಮ್ಸ್ ಹುಡುಕ್ತಾ ಇದೆ, ಮತ್ತೆ ಈಚ್ ಅನ್ಎಂಪ್ಲಾಯ್ಡ್ ವರ್ಕರ್ ಹ್ಯಾಸ್ ಟು ಆಫರ್ 1 ಯೂನಿಟ್ ಆಫ್ ಲೇಬರ್ ಅಂತ ಹೇಳಿದಾಗ the matching function will be M is equal to, matching function is function of U and V, with where M is the flow of matches A, U. That is, we already know A is the probability of getting the job offer. The function is usually assumed to be continuous and differentiable. So this function, matching function, is continuous. That is infinite, for infinite time periods, for infinite number of times, the unemployed worker can continue to search for the jobs. And it is differentiable. Differentiable in the sense, we want to know the rate of change. So if there is a change in time from T to delta T, what happens to the matching function? We can find out by differentiating it. Okay. So with positive first partial derivatives and negative second derivatives. What does it mean? Positive first partial derivatives and negative second derivatives means you are trying to maximize this matching function, or trying to find the equilibrium of the matching function, and to satisfy the constant returns to scale. So a commonly used matching function in the theoretical literature derived from the assumption of uncoordinated random search is the exponential model. M is equal to V into 1 minus e to the power of minus ku divided by V, where k is greater than 0. So this is the most popular matching function that is used for empirical estimation of the matching functions. So you can we can easily convert this into log model and estimate it empirically. The empirical literature. So for this given theoretical model, how do we empirically test it? Going for a log linear model, the constant elasticity form, which parallels the Cobb-Douglas production function specification with the elasticity of unemployment estimated in the range of 0.5 to 0.7. Now, which is this elasticity of unemployment? The K, the coefficient with U here, minus KU. So this K is the elasticity of unemployment, coefficient of elasticity of unemployment, which usually ranges between 0.5 to 0.7 in empirical estimations. So this is the aggregate matching function and the job seeking behavior. when we just considered the expected returns WT and the returns when he was getting when the person was unemployed, that is UT, and the discount rate R, with probability of getting job offers of A and compulsory payment of B, that is of UT, all these things. Okay, now what happens if we include the cost of search? Because there is asymmetric information, because there is disturbances in the information flow. Now what happens, to take up a search activity, you have to incur some costs, right? Without incurring that cost, information is not available. Only when you incur that cost, some information is available to the searchers. So there is a cost involved with this search. Now let us see, try to understand a simple model when cost is involved. Okay. So model with cost of search. So now here, what happens, this contribution is due to J.J. McCall. It is about application of theory of optimal stopping rules. So there we saw limited stopping rules of Stigler, and then sequential stopping rules, and now the optimal stopping rules theory, which was used even by Arrow, KJ Arrow, is applied to study the unemployment phenomena when there is frictions in the market. That is when there is information asymmetry and you have to incur some costs on the searching activity. So the amount of search or the period of unemployment depends on wage rate that the individual thinks his services or her services can command in the labor market, and on the opportunity cost of searching. So now what is the amount of search or cost of search that he has to incur? Or if he is searching, he is in the period of unemployment, he continues to be unemployed till he finds a suitable employment. So what does this depend on? It depends on the wage rate that the individual thinks, that is his reservation price or the expected return for his given set of skills and services, for his job capabilities. That is the wage rate that he is expecting. So that critical minimum, the critical level, or the reservation price. So we can use different terms there. So it depends on that wage rate and then the opportunity cost of searching. Because there is lack of information, there is information gap, the seeker has to take up the search activity, which involves some opportunity cost. The search activity is not free at all. We have to incur some cost. For example, if you want to search nowadays, we think if you want to search anything, immediately you think of Googling it, right? So is it free of cost? Even that Googling involves cost, right? Your internet data connection and all, you are using the data, it involves some cost. So here also, there is opportunity cost of searching activity. So if he or she, that is the one who is seeking the employment, value their skills or services highly, the job offers which fall short of their expectation are rejected and they continue to remain unemployed. So if one thinks that their skills or services are very high and they should get a very good returns in form of wages, whatever job offers they are getting which is short of their expectation, our expectation ಗಿಂತ ಕಡಿಮೆ ಇರುವಂತಹ ವೇಜ್ ಆಫರ್ ಬಂದ ತಕ್ಷಣ ಅವ್ರು ಏನ್ ಮಾಡ್ತಾರೆ, they reject it and they continue to remain unemployed. So again, if the cost of information is very large or high, the individual will tend to limit his searching activities. So ನಾನು expected wage ತುಂಬಾ high because my skills are very good and my services are very good ಅಂತ ಅನ್ಕೊಂಡಾಗ ನಾನು ತುಂಬಾ ಹೈ ಲೆವೆಲ್ ವೇಜಸ್ ನ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಆದ್ರಿಂದ ನನ್ಗೆ ಬೇರೆ ಜಾಬ್ ಆಫರ್ಸ್ ಬಂದ್ರು, ಕಡಿಮೆ ವೇಜ್ ಲೆವೆಲ್ ಆಫರ್ಸ್ ಬಂದಾಗ ಐ ವಿಲ್ ನಾಟ್ ಅಕ್ಸೆಪ್ಟ್ ಇಟ್, ಅದನ್ನ ರಿಜೆಕ್ಟ್ ಮಾಡಿ ನಾನು ಅನ್ಎಂಪ್ಲಾಯ್ಡ್ ಆಗ್ಲಿಕ್ಕೆ ಅನ್ಎಂಪ್ಲಾಯ್ಡ್ ಆಗಿಯೇ ಇರ್ತೀನಿ. ಮತ್ತೆ ಕಾಸ್ಟ್ ಆಫ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಅಂದ್ರೆ ಆ ಸರ್ಚ್ ಆಕ್ಟಿವಿಟಿ, ಆ ಇನ್ಫಾರ್ಮೇಶನ್ ನಾನು ತಗೋಬೇಕು, ಸರ್ಚ್ ಆಕ್ಟಿವಿಟಿ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದಾಗ, ಇಫ್ ದಟ್ ಈಸ್ ವೆರಿ ಹೈ, ಅಗೇನ್ ಐ ವಿಲ್ ಲಿಮಿಟ್ ಮೈ ಸರ್ಚಿಂಗ್ ಆಕ್ಟಿವಿಟೀಸ್. ಆ ಜಾಬ್ ಸೀಕರ್ ಇರ್ಬೋದು, ಎಂಪ್ಲಾಯರು ಇರ್ಬೋದು. ಇಫ್ ದ ಕಾಸ್ಟ್ ಆಫ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಇಸ್ ಹೈ ಎನಫ್, they will limit their searching activity. So now, what is the optimal search policy? Employment opportunities are confronted with relatively high information cost. They may choose the null occupation and not to search for alternative employment. So ನಾನು ಈಗಾಗಲೇ ಹೇಳಿದೆ, null occupation is trying to remain unemployed. ಯಾವುದೇ ಆಕ್ಯುಪೇಷನ್ ಇಲ್ಲದೆ ಇರುವಂತ ಪರಿಸ್ಥಿತಿ, ಅದಕ್ಕೆ ಅದನ್ನ ನಲ್ ಆಕ್ಯುಪೇಷನ್ ಅಂತ ಕರೆಯುವಂಥದ್ದು. ಸೊ ಬಿಕಾಸ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಕಾಸ್ಟ್ ಆರ್ ವೆರಿ ಹೈ ಅಂಡ್ ದ ಎಂಪ್ಲಾಯ್ಮೆಂಟ್ ಆಪರ್ಚುನಿಟೀಸ್ ದಟ್ ಈಸ್ ಗೆಟಿಂಗ್ ಇಸ್ ಅನ್ಅಟ್ರಾಕ್ಟಿವ್. ಆ ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ ವೇಜ್ ಅಷ್ಟು ಬಂದಿಲ್ಲ, ಆದ್ರಿಂದ ಆ ವೇಜ್ ಆಫರ್ ಅದನ್ನೇ ಅನ್ಅಟ್ರಾಕ್ಟಿವ್ ಎಂಪ್ಲಾಯ್ಮೆಂಟ್ ಆಪರ್ಚುನಿಟಿ ಆಫರ್ಸ್ ಅಂತ. ಅವಾಗ ವಾಟ್ ವಿಲ್ ದಿಸ್ ಪರ್ಸನ್ ಡು? ಆಪ್ಟಿಮಲ್ ಸರ್ಚ್ ಫಾರ್ ಹಿಮ್ ವುಡ್ ಬಿ to choose the null occupation and not to search for the alternative employment. So avun en martane, better to because cost is very high, he will stop searching or looking for alternative employments. He will accept his unemployed status, and such people are called as dropouts or discouraged workers. So why they are discouraged? Because they are not able to incur that high outlay on search activity, because information cost is very high and they are getting unattractive job offers. ಅವ್ರಿಗೆ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತಾ ಇರುವಂತ ಆಫರ್ಸ್ ಬರ್ತಾ ಇಲ್ಲದೆ ಇರೋದ್ರಿಂದ ಅವ್ರು ಏನ್ ಆಗ್ತಾರೆ, ದೇ ಬಿಕಮ್ ಡ್ರಾಪ್ ಔಟ್ಸ್ ಆರ್ ಡಿಸ್ಕರೇಜ್ಡ್ workers. So a simple model of optimal search is developed, assuming that the searcher knows the distribution of wages for his skills. So obviously, given my set of skills and services, I know what should be my wage distribution of my wages, and the cost of search is a known constant. So a wages distribution gottide, matte cost of search constant anta assume madkondo we can arrive at a simple model. So C is the cost per period of search. So for each period, each time period, a cost is incurred on search, which is C. X is a random variable denoting the job offer. Delta X is the probability of probability density function of X. So what is the job offer? Probability of the job offer that he is getting, that is delta of X. And f of X is the maximum return obtainable when a job offer X has just been observed. So if one is accepting that job offer X, what is the maximum return that is able to derive from that job offer X is given by f of X. The cost C is incurred simultaneously with the offer X. So a job, in arriving at that job offer, in getting that job offer X, the person has incurred the cost C. So if the process terminates, when does it terminate? Person is getting the employment. So employment commences after n job offers. So n number of job offers band mele he is accepting a job offer which is suitable to him in all the ways. The return F is simply the value of the nth offer, that is say xn, that is the offer, job offer of X at time period n. Okay, and f of xn is the maximum return that he is getting from the by observing that job offer in the time period n. So less the cost of search. So since C is the search cost he is incurring, from that return he has to subtract the cost to know the real returns. So from F he will subtract from xn, the returns from xn job offer, he will subtract the cost that he has incurred in getting this nth offer. So C times the number of job offers. N time period ali avanu C na incur madiradrinda F will be equal to xn minus C into n. If an X is observed at the first period and the process continues in optimal fashion, the return is given by f of x minus c plus maximizing the returns expected value from f of x from a job offer x. So if we let epsilon, this is small e, is equal to expected returns from the job offer x, it is clear from this equation that the optimal policy has the following form. Continue searching if x is less than the epsilon. So epsilon is the maximized returns that he is expecting. So if x is less than that epsilon, he will continue searching, or he will accept the employment if x is greater than that or equal to that epsilon. So following KJ arrow, the calculation of epsilon is easily accomplished. So what is this epsilon? It is nothing but the expected value from job offer x in the given time period n. So the conditional expectation, we study this in probability. What is the expected value of y when the value of x is given? Similarly, what is the expected value from job offer x? That is, what is the expected value of fx in the nth time period where you are offering or where you are accepting the job offer that is given to you in the nth time period. So the expected value of return given that the searcher accepts the nth offer is calculated first. Then epsilon is obtained by expecting out n. So symbolically, expected value of x by n will be expected value of xn, the job offer in the n time period in the time period n, minus the cost of that a person has incurred in all the time n time periods. So expected of value of f will be epsilon, which is given by expected value, overall expected value of this expected value of xn by n minus c into expected value of n. Now we have to notice that y is accepting this offer in the nth period and not in the n minus 1 time periods, because none of the expected values in the earlier time period, that is anything less than n time period, that is n minus 1, were equivalent to this expected value. So none of it reached the epsilon value e, and that's why the person is offering the job offer in the nth time period. So now with a lot of derivations and all, we can arrive at this simple equation which has simple interpretation. The cost C here is the marginal cost of generating another job offer. The second member is the expected, that is on the right hand side is the expected marginal return from waiting another job. So C is the marginal cost of generating another job offer. So we know that if there is a small change from one job offer in time period T, you are moving to another job offer in T plus 1 or delta T, there is marginal cost incurred in getting that job offer in the next time period. That is called as the marginal cost. The second member is the expected marginal return, that is x minus e epsilon delta x dx. So that h of epsilon. So the critical value epsilon of a job offer. So that is the critical value now the job seeker is expecting or the unemployed worker is expecting after considering the cost of getting the offers. Okay. So epsilon age of a job offer is chosen to equate the marginal cost of waiting with its expected marginal return. So now we arrive at the most important applied economics thing, where marginal cost is equal to marginal benefit. So here also, this is the most important thing. Anywhere when we move to applied economics, we see that whether it is in environmental economics, health economics, economics of education, anywhere the optimality rule is where marginal cost is equal to marginal benefit. So here also the marginal cost of generating another job offer is equal to the expected marginal return from waiting for another period. So it is shown that h of epsilon is a strictly decreasing function of epsilon. Why? Because each extra time period you are spending in getting another job offer, you are incurring cost also, right? So there is a unique value of epsilon for every value of C as shown in the next figure. So this model is a convenient device. What is it that we understand here? Here we are able to distinguish between the discouraged workers or the dropouts. As I mentioned earlier, they are the ones who remain to be unemployed given the situation, from the frictionally unemployed. The frictionally unemployed are the ones who are unemployed for a time period until they find the suitable job. So they continue to search. So the dropouts are those they stop searching and they accept their unemployment status. So their decision is based on the relation between cost of search and the wage distribution appropriate to their skill level. The frictionally unemployed are those who are looking for jobs but have not yet obtained a satisfactory job offer for which X is greater than the epsilon. So already I mentioned about this. Until they get that critical minimum level epsilon, they will not accept the job offer. Now, because cost is very high, the cost of searching, cost of seeking information is high, they try to become dropouts or discouraged workers, or the one who are able to incur, that is if their expected wage, expected return epsilon is less than that the cost incurred, they keep searching, looking for jobs and try to remain frictionally unemployed until they find the job. So here, since h of epsilon is a decreasing function of C, that is the cost of searching, large values of C are associated with small values of epsilon and shorter period of search. So what do we understand here? When you are incurring higher cost in searching and it is associated with small values of epsilon, that is your expected returns given the higher cost, and therefore the period of search is shorter. That is, within short period, you are going to find a job offer which is going to offer you that equilibrium level of expected returns epsilon. Similarly, small values of C are associated with larger values of epsilon and longer periods of search. So when cost is less, the values of epsilon are larger and hence the periods of search will become longer. So if the expected returns from remaining unemployed or epsilon not, here in the figure, not searching at all is the best strategy. See, if his expected returns are epsilon naught, and if he is having a high search cost of C naught, which is excess than C naught, at least if it was C naught, he was able to find, he would be able to find a job offer. But if it is beyond C naught, what will be this optimal strategy? Not to search at all and remain unemployed. So the value associated with any value of C greater than C naught is less than E naught, the expected return from remaining unemployed. So whenever that C naught is cost is greater than C naught, which is equivalent to getting a return epsilon naught, he would remain unemployed instead of going for searching by incurring such high costs of searching. So this is another way of saying that optimal policy for such an individual is to drop out or join the ranks of discouraged workers. So this is the model which discusses about finding a suitable job, or that matching function, or arriving at a job offer which is acceptable when the cost of search is involved. So with this, I'll stop with economics of search, and then we can move on to the economics of crime and punishment. So alternatively, if the costs of search are less than C naught. So if it was less than C naught, they continue to search and they become frictionally unemployed until they become employed. The individual will continue to seek employment until he receives an offer exceeding the corresponding value of epsilon. The time until such an offer is forthcoming is a period of frictional unemployment. A description of the structure of the optimal policy is a convenient device for summarizing the preceding discussion. The optimal policy for choosing between dropping out and frictional unemployment as the following form. C is greater than or equal to C naught. Do not search, drop out. The cost of search is very high, beyond C naught. So they will drop out. So, but if the cost of search is between 0 and C naught, they chose frictional unemployment. That means they continue to search for jobs until they find a suitable job offer, because the cost is feasible. They are able to take up the search activity. So this is about economics of search that I was trying to share with you people. There are advanced models which will talk about calculating the length of being unemployed given the cost of search and given their expected returns, that is critical reservation wage that they are expecting, all this. So I think for our refresher course, we will keep the discussion till this model where cost of search is involved, what will be the behavior of the job seeker. So next we will move on to economics of crime and punishment. We want to take a break or shall we continue?
You want to take,
Ma'am.
madam?
Yes?
Ma'am, there will be a break for an half an hour, ma'am, 3:15 to 3:45.
3:15 to, okay, so shall we break now?
Ma'am, I have one doubt regarding your presentation.
Yeah.
Ma'am, you spoke about null occupation. Does that component relevant to country like us? No?
Many will be null occupied. And that is just the term. Why they call it as null occupation is, as I told you, in advanced countries, they provide unemployment benefits also. And there are social security payments for unemployed people. So that's why they have used the term in the theory as null occupation. But here it is typical unemployment only, no null occupation. The government hasn't still come up with unemployment benefits, or we haven't yet reached the level of enjoying the leisure that we get with being unemployed. There, because they have some returns, UT, when they are unemployed also, because of government payments and as I told you, social security transfers and all transfer payments, they have unemployment benefits, all these, some kind of pension payment and all for unemployed. That's why they have used the term null occupation. As you said, for countries like where there is huge population nowadays, this unemployment has become a big debate, right? Policy matters and election manifesto and all. So it is typical unemployment only. There is no null occupation here. They are unemployed. Yes, any other doubts? Anyone else? Or you want to add?